Welcome everyone. Thank you so much for joining us today. My name is Lauren Manier and I am a program associate with the Inclusive STEM Ecosystems for Equity and Diversity, or ISEED program at the American Association for the Advancement of Science, and I work on the AAAS-IUSE Initiative. We are pleased to be hosting this workshop titled Best Practices for Supporting Undergraduate STEM Faculty and Students in the Online Transition, Results of NSF Rapid Awards supported by IUSE. And we are excited to hear from our presenters, Dr. Barbara Means and Dr. Eric Brewe. Before we get started today, I have a few housekeeping notes. The presentation is being recorded, and a recording and the slides will be made available in the coming weeks at our website at AAAS-IUSE.org. You will also receive an email with a link to these materials. Please note that we will have time to transition to a breakout rooms following the presentations. These breakout rooms will allow for deeper engagement and they will not be recorded. Additionally, we have closed captioning for this workshop. You can download and view a full transcript by clicking the CC button at the bottom of your screen. Now, before turning it over to our presenters, here's a little background about AAAS and our IUSE initiative. AAAS, the American Association for the Advancement of Science, was founded in 1848 and is an international nonprofit organization dedicated to advancing science, engineering, and innovation to benefit all people, with the specific goals of strengthening and diversifying the science and technology workforce and fostering education in science and technology for everyone. With more than 120,000 individual members in more than 91 countries, AAAS is the world's largest multidisciplinary science society and a leading publisher of cutting-edge research through the Science family of journals. More information is available at AAAS.org. The AAAS Improving Undergraduate STEM Education, or IUSE initiative, seeks to support faculty, students, and the greater undergraduate STEM education community by disseminating research and knowledge about STEM teaching, learning, equity, and institutional transformation. This year, we launched a website, blog, and workshop series, and today is our second of 6 workshops we will be hosting this year. On our website, you can also find a collection of resources relating to improving undergraduate STEM education and an IUSE proposal preparation toolkit for those interested in applying to an NSF IUSE grant. We invite you to learn more about the AAAS IUSE initiative on our website or LinkedIn page, and we hope that you will join our community as future contributors. You can also follow us on Twitter at IUSE Program to stay up to date on our latest events and blogs, or to share what you've learned today at this workshop. So now, without further ado, I would like to turn it over to our first speaker, Dr. Barbara Means.
Thank you, Lauren. I'm going to share my screen, and hopefully we will. This one would be the right one to share. Okay. All right, if that works okay, we can get started. I'm going to be talking about results of an IUSE Rapid grant that we did work on during the past year, and I will be joined by my colleague, Dr. Julie Neisler, who will help and lead one of the breakout groups. And like all projects, this was really a team, and particularly I want to recognize Julie's contribution to the survey and the data analysis effort. This project addressed 3 main questions. We really wanted to understand the nature of students' experiences with their STEM courses when COVID hit last spring, and compare those experiences to the way they were learning in the same courses before they had to switch to remote learning. So we wanted to see what we could learn from this experience that we could build on in the future. We also wanted to look at the equity implications in terms of the challenges to continuing their work online, knowing that these were likely to impact some students more than other students. And finally, we wanted to get a sense of the practices within those remotely taught courses that were better received and appeared to support students going forward. So those are the three questions we're addressing. We have two main research approaches that we used. I'm mostly going to talk about the student survey results today. So these are our quantitative findings. We drew on an existing survey panel of 65,000 members that the Ipsos polling organization uses. Now, this was a panel that was constructed to provide nationally representative data and to support valid statistical comparisons. And in terms of being able to get out in the field really fast during COVID, this was a real advantage to us. We received our rapid grant towards the end of April, and we were out in the field with the survey on May 13th. So this was a survey of individuals they already had in their panel. So they knew characteristics about these individuals, and they had agreed to take surveys from time to time. And what they did was they contacted those who had completed a high school diploma but did not have a college degree, either 2 or 4 year, and asked them whether they were taking an online or whether they had been taking a college course for credit in the spring before the COVID pandemic started, and whether, if so, whether that course had then transitioned to being taught remotely. And so those people that answered yes to both of these questions were eligible for our survey. Because we were sponsored by the National Science Foundation, and also because many first generation and low income students struggle with their STEM courses in particular, we asked those students who were taking a STEM course at that time that met the criteria for inclusion in the survey, talk about their STEM course. If they had more than one STEM course, we asked them to think about the one they thought was most important to their future. If they were not taking any STEM course, we had them talk about the other course they thought was most important to their future. So in all cases, the survey respondents were responding for a particular course for all of the questions we asked. They were able to take the survey in either English or Spanish. And I will talk today about the results in most cases just for STEM courses. In a few cases, I'll bring in the other course results as well, and I'll indicate when that is happening. So that was the quantitative data that we used in this research. We also conducted in parallel some qualitative data collections, basically through focus groups and interviews. Through our prior work with the Every Learner Everywhere network, we had been working with a number of higher education institutions that are broad access four-year institutions or community colleges on trying to improve their introductory courses, particularly through incorporating adaptive digital learning. So we had access to a number of institutions that joined in our proposal to NSF. And at 10 of these institutions, we did case studies on 22 different courses. You can see the subject areas here: biology, chemistry, geology, statistics. Most of these courses, because of the way in which we identified our partners, had been using digital learning systems as part of their instruction before COVID hit and continued to use it afterwards. So about 80% of the qualitative data comes from course sections that were using digital learning in this way. We also tried to recruit other instructors of the same courses who were not using digital learning before COVID, and students from those courses, but they were less likely to agree to participate. We ended up with 92 students and 29 instructors from whom we collected qualitative data. In terms of the modality, the way in which the courses were continued after COVID, we asked a number of questions of our survey respondents. And so of these STEM courses, 70% of them had recordings of the instructor lectures. That's asynchronous. So that was the most common thing. But there also were about 70% where they said they held synchronous sessions where students could ask questions and hold discussions. So it was usually a combination of both asynchronous access to recordings of lectures plus some synchronous sessions. 60% of them included live lectures, so not all of them relied entirely on asynchronous presentation for their lectures. And about 56% of them used other pre-recorded videos, so they could come from the materials accompanying a textbook, YouTube, PhET simulations, and elsewhere. So talking about synchronous versus asynchronous is a little more complicated when you actually come down to the details of the courses. Now I'm going to move to talking about the challenges that students faced in continuing work remotely. And of course, the first thing that comes to mind from an equity perspective is technology access. And what was that like? And we look here at the proportion of survey respondents reporting that they had issues either with internet connectivity or with hardware or software, and students can't always tell what it is, that kept them from being able to participate in course sessions either often or very often. And you can see if you add the very often, which is navy, and the often, which is the more royal blue together, about 15% of STEM course students had problems with internet connectivity. And a smaller percentage, closer to 6%, had problems with hardware or software. And most of the latter students also had problems with internet connectivity. When you put the two things together, about 1 in 6 students taking a STEM course had internet connectivity and or hardware software problems, often or very often. So although this was a minority, it was a sizable portion of the students. And as you might expect, these technology issues were not equally distributed across different kinds of issues. If you look at responses from students from minoritized racial ethnic groups, and here we included Black students, Latinx students, and Indigenous students, about a fifth of them experienced internet connectivity problems, either often or very often, compared to just 12% of students from non-minoritized groups. That would be white or Asian students. 22% of students from lower income households experienced these internet connectivity problems often or very often, compared to 11% from higher income households. So that's about double the incidence rates. Major hardware and software problems were not as common as the internet connectivity issues, as you could see on the prior slide, but they had the same pattern of race, ethnicity, and income level differences. So the digital learning gap or the digital divide clearly has not been entirely bridged and was not bridged at the time of COVID. Now, there are also a lot of other potential challenges to learning, and the survey asked about these as well. So if you look on this slide, those things that are in the darker rust color were reported as a major problem, and the lighter color were reported as a minor problem. So you put the two together, and that tells you how many students thought a particular issue was a problem. And if it's green on here, they said it was not a problem for them. And one of the things that stands out from here is the most commonly reported problem that students have was staying motivated to do well in the course. So if you look at that, we find that 82% of STEM course takers said that that was a problem, at least a minor problem, and 45% of them thought it was a major problem. Looking at the next slide, you can get a sense of some of the kinds of responses we had in the open-ended question on the survey when we said, what was your biggest challenge? Students really found that the lack of a regular schedule, which is often connected to fully asynchronous instruction, and also the lack of connection to their instructor and their fellow students was something that made it hard to maintain their motivation in the course. So we were struck by how important those social aspects of courses were. Now, we also looked at this in terms of different groups of students. And what we see here, if you look at the green, those are the racially minoritized students, and the blue are the white and Asian students. The motivation issue, the motivation challenge, was similarly prevalent for both of these groups of students. But the other challenges, we saw some significant differences. And these are shown, you can see the asterisks, which were statistically significant. So if you look at things like not knowing where to get help in the course, fitting the course in with home and family responsibilities, and feeling too unwell physically or emotionally to participate, and fitting the course in with work schedules, you see that racially minoritized students faced greater challenges, and that was especially true for Hispanic students than other students. And similarly, we found that women and students from low-income households reported more challenges than did those from higher-income households or males. So what about course satisfaction? One of the survey questions asked them overall how satisfied they were with their course, their STEM course before COVID, when it still included in-person meetings. And then we asked them how satisfied they were afterward. And you can see here that there's a big drop, particularly in the very satisfied. So 47% of survey respondents said they had been very satisfied before COVID, and that was down to 15% afterwards. This slide gives you a sense of where they thought the course fell short after COVID. And it wasn't a matter of assigning this to their instructors as the instructors not being well prepared. They tended to be very satisfied, or at least somewhat satisfied, with their instructors' preparation for the course. But where they felt that they were less satisfied was how well they were learning overall, if you look at the lowest bar on this particular chart. And then we look here on areas, we asked them specific areas to compare the online and the previous version of the course when it included in-class meetings. So the dark green is better online, the lighter green about the same, and the rust color is worse online. And if you look to where the worst online is the greatest, you can see that that tended to be in levels of peer collaboration, how interesting they found the course content. There was a big drop there as well. And of course, opportunities to collaborate with other students. These quotes give you some idea of the feelings that students reported in terms of missing that interaction with their instructors and their students. And the second one in particular, which was from a survey respondent who responded in Spanish, found that it was hard. The person was not comfortable in interrupting, if you will, online. It felt more formal, and the social bonds were less close, and so it was harder to break in and talk with peers and instructors. STEM majors were particularly likely among those students in our focus groups to be worried about how much they had learned in the course and how it would affect their ability to complete their major going forward. The student on the left was even reconsidering whether to continue the biology major because of this experience, of feeling that they might not be able to successfully complete fewer courses because of what happened here. Some students, though, were more likely than others to see remote instruction as just as good as face-to-face instruction. And this is one of the things that surprised me in the data. And so I'll try to explain this in a little more detail. In this slide, the green are the proportion of students who said that the remotely taught or online version of their course was just as good or better than the course had been when it included face-to-face meetings. The light blue said it was worse online, and the navy blue said it was much worse online. So let's focus on the green bars. These are the students that thought that the remote course was just as good or better than the course when it included face-to-face meetings. And in each pair of bars, the minoritized group of students are on the first bar, and non-minoritized or white and Asian students are the second bar. And where you see they were similar in terms of knowing what was expected of you, they both felt that was about the same online as it had been face-to-face. But if you go down the slide and look toward the bottom, places where non-minoritized students felt that the course was worse online, so things like opportunities to collaborate with other students, keeping you interested in the course, a feeling of belonging, that impact was not as strong for minoritized students. In fact, over 40% of minoritized students in each case thought the course as taught remotely was just as good as it had been before COVID hit. I'm going to talk now for just the rest of the time I have available about some of the practices that were associated with better satisfaction post-COVID. On the survey, we asked about 8 particular practices. We took these from the learning science research on what promotes better learning online, as well as from programs that are very commonly used in faculty development. So these activities had to do with interaction within the course, content and activities, and assessment practices. And you'll see these on future slides, so don't worry too much about them. We asked each student whether each of these things was part of the course. And then for each survey respondent, we added up the number of these practices that they said had been part of their course. And so they varied from 0 to 8, of course. And then we related this to the responses they'd given about the satisfaction on the survey. And what you see is that in courses that included more of these practices, the percentage of students who were very satisfied increased. And so the combination of very and somewhat satisfied was much larger when these practices were used, which I think gives us hope in terms of how we do learning that has to be done remotely or is done online in the future. We do know a lot of things about how to do it better. The practices most closely associated with STEM course satisfaction were using real-world examples to illustrate course content, assignments requiring students to reflect on their own learning, and sending personal messages to students, asking about how they were doing, if they needed help, and talking about their particulars of their performance in the course. This chart actually pulls from the survey data from students reporting on a non-STEM course as well. And what we see is that 2 of the practices that are most closely associated with student satisfaction in the course were actually more common in non-STEM courses than in STEM courses. So that was personal messages and assignments that had students reflect on what they had learned and what they still needed to learn. I will skip some of this because I am short on time, so I'm just going to mention that in the qualitative data, we uncovered a number of dilemmas that instructors were grappling with and really saw a trade-off at this time. That one of them was between equity of access, which is facilitated if you make the course asynchronous and put all the lectures as recordings and have everything asynchronous, or you have things that students can download and use later in paper form. And course engagement. When there were synchronous sessions, students were more engaged. Keeping students engaged and really doing deeper learning online was a challenge for many faculty, as was finding the right balance between standards that motivate hard work and being equitable and being understanding of their students at the time. And that relates to assessment and how they assess course learning. I know Eric's going to talk more about this, so I'm going to skip this slide. When you get access to the slides or look at the video, you can see a number of publications available based on this work with much more than I could talk about today. And these are some of the questions about supporting students we'd like to discuss in the breakout group. But in the meantime, I think we have a few minutes left for questions now, which I'll turn it over to Lauren to mediate that, since I can't see the chat.
Yes, so we have a few minutes before we transition to Dr. Brewe's presentation. So if you'd like to post your questions in the chat feature, we can answer some of those. I saw a question come in and your colleague, Dr. Neisler, responded to that one. So we'll move on to another question. It looks like we have a question here. Instructors were relatively ill prepared for the initial transition online. Did you do any later follow-ups?
We haven't formally followed up with these same instructors, but we have gone in and talked to other instructors. And of course, there was a lot of training and a lot more supports that went on over the summer. So we have some colleagues who are who are currently in the process of doing faculty surveys, and they did one last fall compared to the prior spring and found a lot more use of digital learning tools. One of the things I'll say is in our case studies, what came through is those faculty that were already using digital learning for part of their course. So they had in-person meetings, but they also had students learning independently with adaptive learning courseware. They had a much easier time of making the transition in the spring, and more faculty started doing that in the fall, so that they were able to go more easily between in-person classes and teaching at a distance if they had to do it, or various hybrid forms, as I'm sure you know were very common.
Great, and I do see a few questions asking about some of the slides. We will be posting those slides on our website following the presentation, so you can go back and find those links. One other question we have here, is there any one particular mode of delivery or practice instructors should use or avoid? Did you have any kind of feedback on that aspect during your research?
I would say our feedback would be that certainly students found motivation a greater issue when their course was entirely asynchronous, when there was no live online interaction. Now, that live online interaction could have been office hours, discussion groups. It didn't have to be lectures. And in fact, 50-minute lectures were not well received by students. So if you're going to do your lecturing online, I recommend that it's shorter pieces. And as I mentioned, we did find that classes that were already having students do some of their learning with digital systems independently, then were more able to make that transition. And so putting it all together, and this is my opinion, I think that a blended approach with a combination of some learning online and really interactive and more problem-solving kinds of activities done synchronously, hopefully in class. If not in class, then finding ways to do these online is the best way to go.
Awesome. Thank you so much, Dr. Means. And we're looking forward to the discussion breakout rooms following the next presentation, so we can dive a little deeper into these topics. Now I'm going to turn it over to Dr. Eric Brewe.
All right, here we go. Hopefully this will look right, and it does. It seems to look right. Okay. Hi, my name is Eric Brewe. I am an associate professor of physics and science education at Drexel University. And this project was done in collaboration, in partnership with Adrian Traxler from Wright State University. We're gonna just, of course, there we go. Start off with some acknowledgements. We had a collaborative rapid grant, and it supported 2 co-op students, Sarah Scanlon and Adam Ikahara, who were instrumental in carrying off this project. So thank you to everyone. So I'm going to take you back in time to, just over a year ago. March 13th is the day that I want you to think about. March 13th is sort of broadly seen as the day the pandemic closed everything down. The NBA had just canceled its season. Many schools announced that they were closing or going remote. And so if you look at a list, at a Google trend of what were some of the popular search terms, or what was the popularity of the search term asynchronous, you can see that right here, right around the middle of March, was the most popular time that asynchronous had ever been searched up until that point. It has since been surpassed by August 2021, where there was much more searching for asynchronous. So that was one motivation. We saw that everyone was doing something and trying to figure out what they were doing. And then this is from my Twitter timeline, which was a place where I saw a lot of like hashtags, this I teach physics. I encourage anyone that's on Twitter that cares about teaching physics, that's a great one to follow. But I teach physics, and it was filled with people making suggestions and providing resources and saying, how am I going to do this? Because Adrian and I are physicists, and we decided that from this we would take, and we had this hypothesis. We had this hypothesis, which was that by looking into the practices, by looking into how people were transitioning their classes, we would see that faculty are reaching out, they are using social media and the materials that were being developed, and really improving undergraduate education, really improving their teaching. And so as a result, we wrote up a survey, we wrote up a proposal, we wrote up a survey, and we developed the survey. And so once we were funded, darn it, I got too much happening here. Once we were funded, we saw that we developed this survey for 38 questions. It asks about demographics, some institutional data, as well as things about their approaches to adapting courses. From who were they getting guidance from, what tools were they using, and how were they changing their assessment practices? And then some other questions about their career and how they were being impacted by the transition. We also included questions on anxiety that were adapted from the mathematics teaching anxiety scale, and self-efficacy adapted from the Ohio State teaching efficacy scale, which I guess I screwed up and didn't include the date on that. We went about going and trying to identify physics faculty that would be teaching, and we wanted to develop a nationally representative sample. This was our effort at doing so. So what we did is we went to College Navigator, which lists the 10 largest, or lists all the universities, but we chose the 10 largest universities in each of the 50 states, plus DC, the Virgin Islands, and Puerto Rico. And I thought Guam, but maybe not. And then we actually included the 20 largest schools from the 5 largest states. So essentially this gave us a list of roughly 600 schools. We then went about scraping emails from physics faculty pages, resulting in roughly 14,000 email addresses. Now, some of these email addresses were inappropriate. They were the marketing person in the physics department or an advisor in the physics department. So this 14,000 is a much larger group than it probably should be. We delivered the survey on May 18th, and we closed it the first survey on July 7th. As a result, we got 1,052 responses. of which 662 were people that taught physics. And so that's what we're going to analyze. We got responses from 49 of the 50 states, plus DC and the US Virgin Islands. And so I'll talk a little bit about who has responded. First of all, we see that the faculty that responded were predominantly white. However, that sort of matches the ethnic backgrounds of physics faculty that are published by the American Institute of Physics. So while we would of course have welcomed more diversity in our responses, this is fairly representative of the people that are teaching physics at the collegiate level. We asked about gender. It broke down predominantly male, but that is relatively representative of physics, unfortunately. By and large, the people came from four-year colleges and universities. There were some from private colleges and universities, very few two-year public colleges. And I think one of the reasons for that is many community colleges and two-year colleges don't list their faculty. And perhaps that's because there are a lot of people that are adjuncting or itinerant faculty. And so they just don't keep up. And so this was a limitation in our study. We also collected this data to see, where are people coming from. We saw a lot of people from urban institutions, some from rural, minority serving, not nearly as many from historically Black colleges or universities. That was a failing in our sampling probably, but there's no undoing that now. All right, and then we asked them about, well, who is it that, what degrees are you offering and how much are you teaching? And so what you can sort of see, or what I hope you can sort of see, is down here in the lower right, most of the PhD granting universities, they're teaching about one class per term, whereas people that are, places that are offering associate degrees are teaching much, much more. And there's a bit of a mixture in with bachelors and masters. All right. So the basic timeline is then that on or about March 13th, which was a Friday, faculty tended to be put in a position where they had essentially, a common response was, oh, my university extended spring break by an extra week. So going into March 13th, that was spring break week. They got an extra week of spring break. And from there, they went ahead and that was when they transitioned to fully online. So first of all, it should be noted that by and large, people had very, very little experience with teaching online. The places that had the most experience were you had at bachelor's and master's granting institutions, not quite 25% of the faculty surveyed had some experience, but the overall number, I think, was 78% had no experience with teaching online. And so we're really going into this fairly blindly. We found that most people continue to meet synchronously, some met asynchronously, and some used some combination of the two, which is consistent with what Barbara has just said. So when we wanted to know, well, what is it that they did, we can see that, first of all, what sorts of things did they change? So number one, many universities, and this I don't know was a university thing or whether it was a faculty thing, but faculty reported that many of them offered pass-fail options. And so that's probably at the university level to some extent. These other things are things that were done by and large by individual faculty members. So reducing penalties for late work, changing or eliminating exams, using new and different assignment types. Some people said that there were very few changes or no changes. And there were a variety of other opportunities. And I would say here, one of the things that sort of struck us as we looked at these data as they came in was there was a much more empathetic response than physics faculty might typically be estimated to be using. But that's, so that's good. We would hope that the faculty are displaying empathy towards their students. Similarly, what is it that they did? What tools did they draw on? Well, unsurprisingly, as we're sitting here on Zoom all together, everyone tried to learn about how to use Zoom. And nobody was using this before in their classes. So this was a big change, over 75% there. But they also drew on their the features of the learning management system. Physics is a challenging class to teach online because there is a heavy lab component to many classes. So online simulations and demonstrations became important elements. Many faculty reported to use these test administration type things. And you can see that there are a variety of other approaches that faculty use, tools that they integrated into their teaching practices. And one of the things that we think is important here is that because so many faculty were using features of their video conferencing, it suggests that other things were, what they were doing is in a crisis situation, they were essentially finding ways to offer these lectures online. All right, and we'll come back to that sort of at the end. And this is where we get to the question that Adrian and I, and I'm going to take the blame on this one. I was just wrong. I thought, based on my Twitter timeline, it sure looks like everybody's talking about teaching and how are we going to do this and what kinds of strategies can we use. And so when we asked them, well, who is it that you talk to about teaching? That by and large, they talked to other people within their department. So that was their number one group. But also teaching and learning centers at their own institution, which includes sometimes STEM centers, sometimes just teaching centers. So the teaching center became very important. The instructional learning management system, and then faculty in other department at my own institution. So notice these 4 top bars suggest that the understanding of the local context is really, really important. And then if you go down and you look all the way down here, just above textbook companies, we see social media. And so while I was looking online at social media and finding things about teaching, others just clearly were not. And so, you know, that meant that the nature of our project has changed somewhat. And so that was an interesting finding, and it's always exciting when your data are different than you expect. So I'll talk a little bit about how this impacted faculty. The first thing is we asked about anxiety. So we had a series of 3 questions about their responses to teaching online versus in person, and then we aggregated them. And we see that overall, you know, this line right here suggests that there's equal amounts of anxiety online and face-to-face. And unsurprisingly, there is a much larger level of anxiety for teaching online than in face-to-face settings. But that everybody, and not everybody, but almost everybody, thought that they were doing a pretty good job of it. So I think it's roughly 90% of our response rate, or of our responses, were above or average or above. And so this is sort of the Lake Wobegon effect. You know, everybody's above average. When we went and looked at this efficacy result, we went and I don't want to add. We tried to find features that were in the data set that told us about who was being effective. And so we used a Bayes factor approach. And one of the reasons we used a Bayes factor approach, Bayes factor is similar to more standard frequentist statistics, but it tells us about the strength of the belief in the null hypothesis, in that there's no good reason. And so that's what this table shows us, is that we didn't see gender as, gender was not a factor. Course level was not a factor. Institutional type was not a factor. Job security was not a factor. Experience with remote instruction was the closest thing to a factor that told us about something related to why they saw themselves as being more effective. And faculty rank was unimportant. And so we're going to stop here, but we're going to say that basically in times of rapid change, our hypothesis is that people were drawing on these weak ties through social media. And in fact, that ended up not to be the case. In times of rapid change, faculty drew very heavily on these strong ties, faculty within their department or at their own university. And we think that it's because context matters quite a bit. Faculty are much more anxious about teaching online, but also think that they're doing pretty well at it. That they displayed some measures of empathy towards students. And we think that there might be signals of an entrenchment of lecture, and we will be able to answer that better because we have, in the future, we have a follow-up survey that we have already done. We have resurveyed our sample, and we have some results there, but not yet ready to present. And the goal is to answer the question, did having a summer to prepare faculty really help them, do a better job of incorporating different approaches or different tools, drawing on different resources? And I said that this project has changed. We thought of it much more as a social media project, and in fact, we find that it's got a much richer qualitative component. We offered an open-ended question. Of the 600 people, 400 people responded with in-depth responses about their sentiments about online teaching. And so we thought that was a pretty interesting result, and we hope to be exploring that further in the year that comes. And so with that, I'm going to say thank you, and I'll be happy to take questions.
Thank you, Dr. Brewe. If anyone has any questions, please feel free to post them in the chat. We have a couple of minutes to answer a few questions. I don't see any questions right now, but I was wondering, is there anything you found surprising while you were doing your research?
We found a lot of things that were surprising. Number one, we really thought that faculty used social media, and in fact, we don't think that that's the case anymore. We are, as we go through the qualitative data, the data about what faculty were doing and how they felt about the experience. One of the things that sort of struck us was that people were struggling with this, and it was in many cases faculty that were more experienced, which is a nice way of saying older, more experienced were struggling more. And whether it was with the technology or whether it was just with being isolated, and that was really gut-wrenching and very challenging. We saw that there were some departments that were very coordinated and some departments that were less coordinated about their responses. And so that's all in the qualitative data. And so those will be coming later. But for now, we're really, I think we were surprised at the level that context, the knowledge of the local context seems to matter a lot.
Mm-hmm. Awesome. And I do see a question from earlier. How does this work draw on Carl Wyman's recommendations to improve science teaching?
Well, I mean, so one of the things that we were sort of hoping, instructional change is a slow business, right? And this, the fact of the matter is that COVID-19 has disrupted or unfrozen the instructional practices of large groups of people. And so it just makes sense that this is a time when we see big movement in instruction. Now, a lot of the things that Carl has advocated for, we also would advocate for. And we were looking to see, did we see any signal of, hey, this is an opportunity. I'm changing things because I have to change things. Am I going to also implement some of these things that are recommended? And this is asking an awful lot of faculty. And so it'll be interesting. It's probably not surprising that during our first survey, which really only covered the spring of 2020, that we see much. It'll be very interesting to see how things have changed from spring 2020 to fall 2020.
Mm-hmm. Great, and I think we have time for one more question. I have a question here. Did you include instructional designers as resources? Maybe they were folded into teaching centers?
Yeah, I mean, that's hard. I don't think we have a viable way of answering that. I think that there's not a standard way that instructional designers are incorporated into physics departments, and really we were focused on physics departments. So I don't think we can say that, but I see in the chat there's a lot of discussion about where these people exist, and as they exist in different spots, it's very hard for us to say.
Mm-hmm.
Yep.
Okay, great. Well, I think it's about time to transition into discussion. So hopefully these unanswered questions can be discussed in discussion rooms. Okay, so we are now going to navigate to the breakout room portion of the presentation. Hi, everyone. Welcome back to the large group. I'm wondering if we can get our facilitators and speakers to share a quick 1-minute recap of their group discussion. So I see Julie here. We'll start with Julie.
Yes. Hello. Thank you, everyone who participated in our discussion. So we talked about students, and the overwhelming consensus was that the results generally tended to align with that Dr. Barbara Meads presented, and just that students really struggled, and it was almost not really related to the courses that were being taught. That faculty, responded really well, did what they could, provided cell phone numbers, started having, here's just 20 minutes of time, let's chat together. To try and really support students, and really just noticing that students were dealing with internet connectivity issues, dealing with all the things that Barbara spoke about. When we talked about some of the things that they had done to support students, I mean, instructors, you should all give each other a round of applause, right? Worked incredibly hard over the last year, giving out their cell phone numbers, trying to be as responsive as possible, providing flexibility. They talked about how many of those things will continue forward, right? So the trying to be available, we gave some tips about maybe using a Google Voice phone number instead of your personal cell phone, talking through, how can we facilitate those breakout groups that students really enjoyed when they were in online classes and facilitate those still in person. And then really just reiterating what Eric spoke about earlier, and that empathy was the overwhelming need to have and to embrace and to feel for both yourself and for your students in those experiences. And just thank you to everyone for this conversation. It was great.
Awesome. Thank you so much, Julie. And it sounds like a great discussion. It's great to hear the positive improvements that faculty and instructors like you all are making. So thank you to everybody. Let's turn it over to Adrienne to provide a recap from her discussion group.
Sure. So we were talking about the supporting faculty side of things, and a couple of themes that came up in there. somebody noticed that there seemed to be kind of a polarizing of faculty opinions about online education as the whole thing kind of goes on a little bit longer. People either seem to be ending up in the camp of, okay, this is great, or at least this is important and we need to be doing more of it, versus this is terrible and we need to get back to the way things are supposed to be kind of as soon as possible. That there seemed to be kind of like that split happening. We talked a little bit about reasons why talking to local folks was so much more prevalent than drawing on any kind of internet resources. Given the really strict time limitations that everyone was under, and also at the same time, this enormous kind of information overload that was happening. So everyone was getting, just a crap ton of emails with, no matter how wonderfully explained and researched and resourced, things you could use in your classroom, it was still just such a flood of information. And so having, that flood of information and at the same time, very urgent and very locally specific needs, there was a big push for people to talk to. So, if you're teaching, I think a measurement lab was one of the examples, it makes sense to talk to the person whose office is next door, who's taught that same class, who has specific ideas about that class and knows exactly what resources you have at your institution. And finally, one question that came up that I didn't circle back to as much as I meant to is, what did we learn from all this? What lessons are we going to take forward? And I think one that really stood out for me from the data was the importance of building better online communities for faculty and focusing more professional development on kind of building those online communities. We're still in the middle of it now, and unfortunately, I suspect this is not, COVID-19, I don't think is going to be the last pandemic problem in education. So I think that's one of the big lessons for me, is that need for community is there, that impulse to draw on local community is there. And so we need to be focusing more professional development on kind of building those things.
Awesome. Thank you so much for sharing that recap. I wanted to close with recaps from our speakers. So Barbara.
Well, I will just recap. We had a great discussion group. Thank you. And I will only scratch the surface of the things we talked about. There was a real focus on supporting, or the issue of students' sense of belonging and being able to collaborate when learning remotely. And so we talked about some of the tools and techniques that might help go beyond having breakout rooms per se. How can you make sure that they are really actively interacting with content, and that students feel included and involved in them? So we talked about use of some tools like having specific problems that you're asking different groups to work on, having them use, say, things like Mural or Jamboard to put their ideas on, and where the groups will be able to see each other's. But first and foremost, having shorter breakout groups where they're organized around a specific question, and then you come back. So it's really shorter pieces and more lively, if you will. So we talked about the importance of that. Naturally, we talked about the range of different student needs and how you help pull together the different resources that might be available on a campus. The Learning Assistant Program at Seattle University is one, as an example, having somebody that's kind of an ombudsman between students and those resources. Also, communication. Having a communication plan as part of the as part of a course, so where faculty are really very deliberate in thinking about how they reach out to their students and keep them included. And I see we're running late, so I'm going to stop, but it was a great discussion. Thanks.
Awesome. Thank you so much, Barbara. And Eric, could you provide a quick recap?
I'll do it in just a second or two. While we talked about a lot of things and had great participants and participation, we talked a lot about the challenges of labs and field experiences as really difficult. And then, I would say that I would echo Adrian in saying that community came up in several occasions. And so while we talked about lots of different things, those were two of the things that sort of came up in several cases. So, and thank you to everyone.
Yes, thank you. And before we go, I just wanted to thank our speakers and facilitators and the rest of the AAAS-IUSE team and all of you who are able to join and participate in the discussions and listen to presentations today. Thank you so much. We do have a post-event survey link, which we are posting in the chat and sending by email. The survey should only take a few minutes, and we'd really value your feedback. Once again, thank you all for joining us today. We look forward to engaging with and learning from you, our AAAS-IUSE community.